So this one is topic 2 from ATP, the mass, volume, and density. These are the key points which you should remember before solving this exercise. You all have the hard copy, so use a hard copy. The class is carrying out an experiment to determine the density of a glass. Each student has a test tube as shown in figure 2.1. You have to measure the length. You have to use your ruler or the scale, measure the length and tell what is the answer. And measure the thickness of this, the external diameter. Use your ruler or the scale and measure the length first. Your length might be different from the actual value because the paper size, as in exam, you don't have A4. So your paper size will have a different width as compared to exam paper. That's why when you will measure the length, it may not match with a marking scheme. So what is the length of this test tube? How much, what's the total length of this test tube? Using a scale or a ruler, measure this. It's coming out 12 centimeter, okay? But if it's for you, it's coming out 12 centimeter, that's correct. Because you will write 12 centimeter here. Yeah, for if 12 centimeter, so you will write 12 centimeter. But the marking scheme answer for this one, because as I mentioned, the measurement answer may not be same as the marking scheme. The marking scheme answer for this one is 14.7 centimeter. So why it is different? Because the paper size is different. It's not about you did any mistake. The paper size is different. That's why you are getting a different answer. So it's not an issue at all. You just measure according to the length and you write the answer. So this one is for you, it's 12, so write 12. But I will write the marking scheme answer, which is 14.7. So the length is 14.7 and the diameter, when you measure, you're getting 2, but the answer from the marking scheme is 2.5. But as I mentioned, you don't have to copy the answer, as you will not have the marking scheme in exam. You will use your scale or the ruler and measure the length and the diameter. Yeah, we will measure from tip of the arrow, both sides. Here also from tip, we'll measure this diameter, the external diameter, and we measure the length. A student used 2 wooden blocks to help him out to measure the diameter of a test tube. Describe his method. You may draw a diagram, include one precaution to ensure that the values of a diameter are reliable as possible. So how we can measure the external diameter by using the 2 wooden blocks. So what we should do? Anyone? If I want to measure a diameter, the external diameter, thickness of the tube, thickness of or diameter of a sphere. Yeah, that's good. So what we do, we will place this test tube. So what we simply do, like these are like this is a test tube. You're looking from the side way. Or you can also draw a test tube in this manner. And you place the 2 wooden blocks next to this test tube and place a meter rule or the meter scale. And we will measure the diameter, the external diameter of this test tube. That's how 2 wooden blocks can be used. And whenever you draw any diagram, it should be labeled. Like I should label wooden block, test tube, or meter rule. It's not like you just draw and that's it. That is not the way. Whenever you draw, it should always be labeled. So this is a wooden block. This one is a meter rule or the meter scale. And here is a test tube. But what if we place a test tube in the way, if you place a test tube horizontally, what if you place a test tube horizontally, then how it should be placed? Like if this is a first wooden block, so this is the first wooden block, then the second wooden block, and then you should place a scale or the ruler, the meter rule next to this. So a meter rule or the meter scale should be placed next to this, like this. But it won't be accurate because the thing is, it will be difficult to keep the wooden block on the test tube. Like the sister, like if one wooden block is at the bottom, then test tube, and then you place another wooden block at the at the top, it won't be that accurate as compared to when you place it vertical. Then how we can make the results are reliable as possible? So we should avoid a parallax error. We should look perpendicular, and we should repeat the experiment. Like it's not like only one, avoid parallax error and repeat the experiment. So this part, like repeat the experiment, take the measurement twice. And we'll take the measurement at least twice. So that it will reduce the look perpendicular, avoid a parallax error. You can mention that as well. The next one, in paper 6, you don't have to memorize any formula. The formulas will be given. You just have to use them to get the answer. Assume that the test tube is approximately cylinder. Calculate a value for the external volume. So how to get the external volume? So external volume dimension, it is pi d square L by 4. The value of the pi is fixed, 3.14. What about d? D is the diameter which we get in the first one, that was 2.5. So 2.5 square multiplied by length. What is the length of the test tube? The length of the test tube was 14.7. I'm using the values from the mark scheme. So length is 14.7 and divided by 4. So when you simplify, what's the answer for this? What is the external volume of this test tube?
28.8 according, sir, to the marks scheme.
So marking C value, you got how much? I think there's a mistake. Did you square that?
Square, no, sir. I will
You
make
have
it
to.
now.
Yeah, what's
72.1.
72.1. So 72 centimeter cube. Then moving on to the next part. The test tube is completely filled with the water. So what we did, we took this test tube and we filled the test tube completely with the liquid. It's completely filled with a liquid. And then the water from a test tube is poured into a measuring cylinder. So this water we poured into this measuring cylinder. The reading, read and record the volume V2. What is the volume V2 here? What is the volume V2? So when you check, there are like example 24, between 20 and 40, there are 10 lines. So each line is representing 2. Each line is representing 2. So when you check, this will be 42. This will be 44, 46. Like this is 50. Then 52 and 54. So correct answer is 54. Don't be in rush to solve such question. Like these are free marks. You just have to read the scale and get the answer. If you are, so just check, because between 20 and 40, there are 10 lines. So it means each line is representing 2. So if each line is representing 2, so after 50, there is 52 and then 54. So it is 54 CMQ. So this was 54 centimeter cube. Then describe how would you read the measuring cylinder to obtain a reliable value of the volume of water. You may add to figure 2.2 to illustrate your explanation. So whenever we are reading a measuring cylinder, we should always look perpendicular. So you can also draw an eye here, and we should always look perpendicular or 90-degree. So look perpendicular and read the bottom of the meniscus. That is always the important part, that you should, to avoid a parallax error, you should look perpendicular. Even you should read from the side of the scale or marking, and read the bottom of the meniscus. The next one, the volume V3 is V1 minus V2. Like volume of the glass is external diameter minus internal diameter. So this was 72 and this is 54. So you just have to do 72 minus 54, which is, so that's equal to 18. So this will be 18. We write a look perpendicular to measure. Yeah, look perpendicular, because here we don't need a ruler or the scale. The measuring cylinder itself, it's having its own marking. So we don't need a ruler or the scale. We are not measuring the height, we are measuring a volume. So capacity of a measuring cylinder, there it's always calibrated. The markings are there. So we just read that marking. To read that marking, we should always look perpendicular to the marking of this measuring cylinder. The next one student uses a balance to measure the mass M of a test tube shown in figure 2.3. Calculate the density of a glass by using calculate density by using M divided by V3. So V3 is 18 and M is 32.17. What is the density? 32.17 divided by 18. So 1.78, but here it's of 2 mark. The units also you have to write. The unit of the mass is given gram and the unit of the volume was centimeter cube. So it is gram per centimeter cube. Other student using a balance which only measure to the nearest gram. Record the mass M of the test tube to nearest gram. What will be the nearest gram for this 32.17?
It will be 32.
32. Not, we don't have to round off the density. We have to round off the mass, because the student used a balance So the mass should be 32. The answer, because we need the mass here, that's why it is 32. The precision of the balance does not affect the accuracy of this experiment. Suggest possible source of inaccuracy and what effect this inaccuracy will have on the density. So what we did in this experiment, what might be the inaccuracy? You can see this part. What we did, we filled the test tube with a liquid and then we transferred that liquid into a measuring cylinder and we read the volume of the measuring cylinder, volume of the liquid inside the test tube. This is the part which may leads to an error. How this part may lead to an error? Maybe one of the possibility that test tube might not be completely filled. So if the test tube is not completely filled, this volume will be wrong. Or maybe what is the other possibility? When we transfer the liquid, some of the liquid might remain in the test tube. Not all the liquid. Your water could spill. That is also, water might splash. That is also acceptable. Any reference is acceptable. Like some of the water may remain. Some of the water may remain in the test tube. Or another thing, what is another possible source of an error? As student measure the mass here, you can see student measure the mass of the test tube. So there might be some water in the test tube, so this mass won't be accurate. So what are the possible sources of the errors? If you get greater mass, look, if it is not completely filled, this volume V2 will come out small. So V1 minus V2 will be large, or V3 will be big. If V3 is large, density will be low. So the test tube, the one of the possibility, the test tube is not completely filled. As a result, the V2 will be small, and then V3, which is equals to V1 minus V2, will be large. And if V3 volume is large, the density will be lower. Is it clear, this one?
Yes, sir, clear.